done. Seems like the time already passed. Right? Okay. Today's review day. We can just solve lots of problems. I assume you just already solved problem, review problem. But if you didn't finish it, it's just still, you have time to do it. So do you have any question about this?
Go around.
Yeah, it's a review day. We can do all of them. Right. Calculate solubility of that guy, PbBr2. Okay. Solubility, let's use S. You can use X, but let's use S. And PbBr2, this guy will dissociate in the water, Pb2 plus aqueous, 2 bromide aqueous. This is solid. Initially we already have this guy as common ion, bromide 0.20. Sodium has nothing to do with this reaction, so you don't have to worry about it. Even though it has coefficient 2, you do not multiply by 2. Okay? We have this much concentration in the beginning. So later, at equilibrium, if S amount dissolve, I have S amount, is 0.20 plus 2S. Because of 2, you have 2 of them. So my KSP for this guy is S times 0.20 2S square. Why don't I write one more thing? KSP is equal to that times bromide square. I can put this guy right there. But we can assume that this will be 2S will be very small compared to 0.20. Why? We just assume. This is assumption. I don't have any, justification yet. Okay? Which means this might be wrong. But most time it will be correct. But again, you have to check, double check. Okay? Let's do this. So as an approximation, 0.20 square, which means 0.040 S. And the KSP is not given, which means you're going to have to look it up. What's the KSP?
4.6 times 10 to the negative 6.
4.6 times 10 to the negative 6? Okay, that's your KSP, 4.6. So using this number, do that, my solubility will be 4.6 minus 6 divided by 0.040. So that will be that divided by that will be 10 to the minus 4. That divided by 4 will be 1.15. For 2 sig big, so round right there, 1.2, 10 to minus 4. That's my solubility, which means concentration. Now let's compare this number here. If we multiply by 2, this will be 2S will be, I have to justify my approximation, but there's no reason I can assume it. If you multiply by 2, then we 2.4, 0.00024. If you compare this guy with 0.2, yes, you can ignore that number, right? So this is just fine. I did that without any justification. But most time you can do it, okay? You do not, if you use a certain problem, you cannot ignore that. Right? Okay. So what's the answer? They're asking solubility, so this is the answer. This is the answer. Calculate the molar solubility. And KSP is this. Okay. So we are still looking for solubility. So if we say again, if S S amount dissolve. This will be S. This will be 3S. So my Ks key is iron times hydroxide raised to the third power. And if I use that, iron is S, hydroxide is 3S, and I have Q. So 3 to the cube is 27, S to the cube is Q, so S4. Okay. And then KSP is given 2.5, 10 to the minus 39. And to find out S, wait a minute. calculator 몰랐으면부터 this is pH 12. Okay, alright. Now we don't use this approach because this was given. So last time when I did, this approach will be used only if none of them are given. Okay? If none of them are given, you start from here, that much dissolve. But in this problem, pH is given. If pH is given, POH also given as 2. If POH is given, hydroxide concentration is given as this, right? So because one of the constants is given, we are not assuming from starting from here dissolve just like that. It's not like that. Okay? So you use this guy. So what you do is everything is okay, but we cannot assume this. We cannot assume this because one of them are given. So everything is okay, but not using this. Okay? So then, since this one is given at initially, that is 10 to the minus 2, which means 0.01. 0.01. And we do not know this guy, nothing else is given. So you can still use an equilibrium. If S amount dissolve, this will be S, this will be 0.01 plus 3S. Okay. So here I can use iron concentration S, and the hydroxide concentration is 0.01 plus 3S raised to the third power. Okay. I know this number, so now we are looking for S. Can we assume 3S is negligible compared to 0.01? We always assume that. Okay. So that will be S 0.001 to Q, which means 10 to the minus 6. This is 10 to the minus 6 and S. So my solubility, if I use this expression here, KSP and this, my solubility will be multiplied 10 to the minus 6 over there, that is 2.5, 10 to the minus 33. And then my 3 times S is really so small compared to that, right? It's definitely just 5. So answer is this. Because they asked solubility. That should be the answer. Alright. Equal volume of this and mixed together will precipitate form. Okay. So when you have this kind of problem, you just try to combine this positive ion with that guy, or this with this guy. So which means together you're gonna have Mg, C2O4, or NaCl. Now NaCl is not precipitate in water, right? Because it dissolves. So we are not considering this one at all. At the same time, KSP for this compound is given, so obviously we are looking at that guy. Alright? So, KSP expression for that is KSP is, because this guy dissolved as magnesium, and this KSP is just simply that. Now concentration is, we are using equal volume. Because it's equal volume, when you mix it, concentration becomes half. Right? Yeah, concentration becomes half. So magnesium concentration will be half of that, 0.0050. Concentration of that guy is again half, which means 0.015. So if we multiply by this is not KSP because concentration is given, so this will be Q. Right? Expenditure equal, the same, but if concentration is given and then they did say equilibrium, so there will be Q. So that number is what? .5, 7.5 10 to the minus difference. And the KSP is 8.5 10 to the negative 5. So which one is greater? That one is greater. So Q value is smaller than KSP. So that means no precipitate. Now then, let's move on to first of all, these are the things you're gonna see in the next this coming exam. Okay. So when we give anything that obviously if you study a lot, that will be better. But if you are wondering about certain problem that can you have to do this or not, look at this information. If the question you are wondering doesn't show up here, then do other problem first. If you have more time, you can do all of them, that'll be fine. But if you are not if you don't have enough time, solve a problem that are in here first. Okay? So with that, now we're gonna start. You're gonna start asking questions from the review problem first, and then our practice exam, and in-class quiz. We do not have enough time to cover all of them, so I encourage you to ask questions. Actually, you tried and you didn't, you have a hard time. So after that, if you still have time, you're gonna just solve as many problems as possible. Okay? Especially, I'm gonna put priority. If your question is related to one of this, I'll address that first. Okay? So from the review problem, what? Tell me the number. Question number 1. 19? Calculate the hydrogen concentration of this, mix that, K value is that. Okay. So we have concentration of amount of this guy is 100 milliliter and 0.1. If we multiply it with 10 millimole. I have 10 millimole of this, and the conjugate base from here 0.15 times 50, 7.5 millimole, and nothing else. So if you do that reaction, small amount will be used up, all used up, that will come up to product. Because that much used up, I have left over 2.5 millimole over here. When I look at my product, I have acid and another acid. And the one is strong acid, the other is weak acid. Which means I don't have to worry about this later. I ignore this. I'm just strong acid. So concentration of strong acid is 2.5 millimole inside of total volume 100 liter plus 50, so 150 milliliter. Milli cancel, remaining is more. 2.5 divided by 150. Divided by 150 is 1.6 260, which means actually 1.7. 0.017. Because they are asking concentration of hydrogen, you don't have to do pH calculation. What next? 14. All right. Ooh. Okay. They are asking net ionic equation. The ionization of weak base will be because ionization weak base with water hydrolyze because weak base will accept hydrogen ion and the water turn into hydroxide. We have to include phase. Ionization of weak acid. It's weak acid, so you could use AQ, H plus AQ, or if you want to include, so as a second answer, if you include water explicitly, either way will be fine. Then instead of hydrogen ion, it will be hydronium ion. Rest of them are equal, same. Bromide reaction with water. If bromide with water, bromide is from strong stuff, so it doesn't react, no reaction. Ammonium with water. Ammonium with water, because they say water, let's include the water explicitly. Although you don't have to. There will be ammonia AQ, and hydronium ion AQ. If you do not include H2O, this answer will be still offsetted. Hydronium ion AQ, ammonia AQ, H plus, that will be also offsetted. Reaction sodium with water. Sodium is linked to strong stuff. So if this guy with water, there will be no reaction. Next question.
Can I take a picture of that real quick? That was real quick.
Yeah, I didn't think about this, but I tried to do the match. Okay. So you have limited hour, but you want to do maximum. Take a look at the maximum. Question number 1.
27.
27. pH of buffer containing this. KB is there. Yes. Wonderful choice. 믿으려는 얘기죠. So they already said pH is this. So pH buffer is this. Now we need to find the pH. So let's say this is the initial pH. We need to find the final pH. So answer for change in pH will be final pH minus initial pH, right? We need to find out that guy. pH is, because they said buffer, we can just simply use 핸드사슬바. Ka value is given, not given. Kb is given. Because Kb is given, Ka will be 10 to the minus 14 over Kb. Okay? So now we know what Ka is. This number will go right there as negative log of Ka. So we know that. Now we have to find out concentration of acid base pair. In this reaction, acid is ammonium. And base is ammonia. And then amount of ammonium we have is 0.1 molar and volume is 1. Volume is just 1 liter. So volume doesn't change. So that was constant initially, but we are adding that many more of HCl. So we can just still call this as 0.10 mole. Why? Because volume is 1 liter. And then many more of acid, then many more of base. But if I add this many more of strong acid neutralize base, right? So you're gonna lose this amount. So I have base, originally that many more, but I'm gonna lose this many more. But the thing is, everything happened in the 1 liter solution. This will be still more at the same time more negative. Ammonium will be increased because this guy will convert base to acid. So you are adding this much number to that. But unit was more. Actually, I didn't have to convert to more because it was 1 liter. It's the same thing. So I have that concentration. Use that number. exit top one, 0.1015. Is that right?
Mm-hmm.
Okay. Right. And the bottom one is 0.0000015. So 0.0185. You're gonna get number from here. If the K is right over here, okay? So why don't you put those number here? What do you get? What number do you get?
5.6 times 10 to the negative 10 for KA, or do you want the full solution?
Yeah, okay, so I'm gonna assume you did the calculation here. That number will go right here, and the PHI, initial pH is given here. So that difference is your answer, okay? I try to cover as many problems as possible, so I'm gonna just keep the calculation. What's next? But if you have a question, I can keep going, okay?
49?
29,
49.
49. Okay. Balance net identification. If you add strong acid on the base to buffer, then base acid portion will react. And then use single arrow because strong base force reaction. So H2O, F minus. Addition of S, that will be uppercase. This guy react with base portion, which is CO3 minus, making HCO3 and minus. Reaction at equivalence point, titration. Strong acid, strong base. So there is nothing at the equilibrium point. So it's just strong acid meet strong base become water. That's right. Because it doesn't form salt, don't worry about salt. That's a strong acid, strong base. We just have the equilibrium point, the titration of that. Weak base with strong acid. So strong acid force weak base react as conjugate acid. E. So this guy is actually E. No, actually, this guy is okay. This guy is the reaction at equivalence point in the titration of that with NaOH. So strong base reacted with weak acid. And then form water and conjugate base. Dissolution of silver phosphate in acidic solution. Solid react with acid. All those silver will come out as ion. The phosphate combined with hydroxide, making 2 minus.
And then why are they all single arrows? Because they all have a strong acid or base.
Yeah, if
And
you
the-
have a strong acid or base in the reactant side,
Uh-huh.
then they're gonna force the reaction to go to a single arrow.
Okay.
Yeah.
38.
38. Yeah, KSP, right here, right there. So many. Okay. What's the KSP? Then if pH saturated with this. So KSP, so this guy dissociate zinc 2 plus and 2 of hydroxide. So KSP expression is zinc 2 plus hydroxide. Okay. So like the previous case, if you know anything about this information already, you're gonna have to use it. Okay? And pH is given. Because pH is given, pOH will be 14 minus that 5, 3, 4, right? That means hydroxide concentration is 10 to the minus 5.34. So we know hydroxide. We're going to still have to solve if S amount is dissolved. Okay, I do not want to rush. Okay. So hydroxide concentration given already here. That's our initial concentration. 10 minus 5.34 molar concentration. That is our initial. Later, if S amount dissolved, then I'm going to have S amount of this and 2S plus that much. So my KSP is S. What are the S? pH is the KSP of G hydroxide. The pH is given. Wait a minute. KSP G hydroxide is pH of a saturated solution is that. Okay. So this is slightly different situation. They said zinc hydroxide, and then if that dissolve it, equilibrium is saturated solution, right? And then this concentration is not like adding extra stuff. So from context, it's a saturated solution at equilibrium. And this is hydroxide concentration. So actually you could say if S amount dissolve, this will be S, this will be 2S. And then 2S is have to be the concentration. Therefore, zinc is half of this guy. So I can write, so I know this as, so half of that number. That's zinc. And the hydroxide is that number. And we're gonna raise to second power. Okay. That's your KSP. Are you comfortable with this? Yeah. In the other question, that what is different question? I think I think it was my quiz. Let's go back to quiz. Compare. What's the difference between? Go ahead.
Why isn't it 2OH squared?
Why is 2OH?
Why isn't it
Actually, that thing was included here. The reason is that if we know how much dissolve, there will be twice of that. So hydroxide concentration will be twice of zinc. So if I write any number here, it will be twice of this number. But if I know this number first, here, then we still use this will be twice of that. So that's why this will be half of this guy. So this is still twice of that number. Go ahead.
So that's only in saturated solution?
So I'm going to compare that what we did in the quiz, because when you read the question, that how you going to interpret that, okay? So this question was, what time is it? I'm not sure if you can read it. Where's the problem? I think we had a similar problem somewhere. Okay. Here what we did is pH is 12. So this is very similar problem. Okay. pH is given, right? pH is given. Because pH is given, from both problems we will find the pH. In both problems we know the hydroxide concentration, right? And then here KSP is given. Now this problem you do not have KSP, right? And then this one does it say saturated or not? You wanna know how much this guy can dissolve based on this concentration, which means pH is given. So you know hydroxide concentration over there, and they ask how many they can dissolve, which means how much you can add other ion. Right? So that's different interpretation, because here it says in saturated solution. So saturated solution means it already reached the equilibrium. It's not like you have one ion already in solution and you're adding the other way, right? So you should see the difference of this question. Okay? There is some, difference there. Any questions?
Can we do 39 then?
39?
And
Yeah.
that's the-
That's 39.
Mhm.
KS for this was the approximate pH of a saturated solution of this. Very good choice. It also shows KSP and at the same time says saturated solution, right? Let's see. I'm very curious about how that comes out. KSP is given. Approximate pH of a saturated solution. Okay. So again, it's a saturated solution, right? Which means the equilibrium is already settled, right? Therefore, FeOH2 dissolve like this. So KSP should be like that. And if S amount dissolved, it will be S. This will be 2S. Okay. And yes. So you can use this one for S and 2S square. So they make it 4S cube equal to KSP that was given right there. 4.0 10 to the minus 15. So S value will be that divided by 4. Okay, that will be 1. And then take cube root. So that will be 10 to the minus 5. 1.0, 10 to the minus 5 polarity. Now S is what? S is, this is 2S. So hydroxide concentration is 2S. So hydroxide concentration, because, okay. So hydroxide concentration is 2S. Therefore, 2 times this will be 2.0 10 to the minus 5th. From here you can calculate pOH, this number. And from there you can calculate pH. Okay. Next one.
Do we have to square that and then find?
The small one.
Or do we
Which one?
just-
Which one?
Once we get to OH equals 2S, now do we have to square that? Or we just?
Our final goal is finding a pH. So that require pOH. That also require hydroxide concentration. Now hydroxide concentration is 2S.
Okay.
We don't have to scale it unless your goal is finding out KSP.
Okay.
Okay. Yeah. What's next?
45.
45. Consensus red initially was 0.0180. Consensus of chromate initially 0.0250. If you mix it together, volume change, then make concentration change. After mix, I'm going to use as final. The concentration initially that times volume, PV volume was 500 milliliter. But that will give us millimole divided by total volume, which means 750. Chromate, initially that concentration for used volume is 250. If you multiply, we will get millimole. Then millimole divided by total volume. That will be our new concentration. And that's it. Next.
Oh.
Good. Any question?
No, I got it.
Okay, fine. Next.
21.
21. Which of the following will make a buffer? Which will make a buffer? To have a buffer, you have to have conjugate pair, right? Or you have, right? NaOH, strong base. This is just salt. That doesn't make a buffer, right? You should have a weak stuff and each conjugate. There's no weak stuff at all, so no buffer. We have weak stuff here, weak acid. Now, that's another strong acid. So if you have acid, you don't make a buffer. Doesn't matter weak or strong. If you have both acid or both base, that doesn't make a buffer. Third one, we have weak base. So this is strong acid, weak acid do not make a buffer, okay? This one is strong base and how can I say strong electrolyte? Yeah, strong electrolyte. That doesn't make a buffer. Strong electrolyte doesn't make a buffer. Strong acid with weak base. There's a potential there. Okay? To make a buffer, you have to have one from acid, the other from base, and at least one should be weak. There's another condition. If you have strong acid and weak base, strong guy should be lesser amount than weak one. Or we have equal amount. So then it's not a buffer. What happens? What happens is ammonia react with strong acid, then make it conjugate acid. But if you have 0.2 mole before reaction, after reaction everything will be used up, and you're gonna have conjugate base only. Okay? In the end, you're gonna have only conjugate base. So that's not a buffer. D. This is just strong electrolyte. Strong electrolyte, then if you have strong electrolyte, you don't have to consider anymore. Right? Because whatever you have here is a strong one, weak one, whatever you have. One of the guys is strong electrolyte, that doesn't contribute anything. Right? But still make sure that strong electrolyte coming from one, this is from strong linked to strong base and AOH, this is linked to strong acid. So that doesn't do anything. So not buffer. Strong acid, weak base. There's potential right here. And then also, you have lesser amount of strong one compared to big one. This will make a buffer. How? Well, I have weak base, 0.4 mole. I have strong acid, 0.2 mole. When they react, it convert to conjugate acid. So before reaction it was like that. After reaction, small amount will be all used up. They convert to conjugate acid. This will use up half of that. So after reaction, you're gonna have weak base with its conjugate pair. So that's a good buffer.
So, can strong electrolytes never make a buffer?
I'm gonna be a little more conservative. So check if the strong electrolytes coming from actually both from strong acid, strong base. Then they just stay separate, right? So it doesn't do anything further, which means it's practically you have only one kind. Because strong electrolyte will dissociate, doesn't do anything. So that doesn't do anything. Then if you have only one thing, if that is just strong acid, strong base, weak
Okay.
acid, weak base, whatever you have, it doesn't matter. Because strong electrolyte doesn't contribute.
Okay.
Well, you wanna make sure that strong electrolyte really, from strong stuff.
Right.
Because some strong electrolyte This is string electrolyte.
Oh, yeah, okay.
But when they separate, actually it contributes.
So if it's a salt,
Salt.
then it wouldn't contribute.
So I try to consider if there's any exception. So salt and strong electrolyte, I think that doesn't contribute anything.
Okay,
I try to think any exception, but I don't think nothing.
okay.
So if you see one of them are strong electrolyte and the salt, just cross that out. Yeah, maybe.
Can we do 18?
18. Equilibrium constant of acetate in the solution which this has HC and HCl. Okay. So before reaction we have acetate ion 0.300. This is not acetate ion. That should be 2 0.3 몰라? And 0.25 acid. 0.2
The 0.300 should be on the other side, right?
No, it was a typo.
what?
With the acetic acid.
Wait a minute. Oh, acetic acid. Okay. Wait a minute. What did I do? That's acetic acid. Okay. 0.300. And then we don't have that. Special bonus. So after reaction, no, they do not react. 0.30 acetic acid, okay. 0.5 HCl, we don't have anything else, okay. So they do not react. Then we have weak acid and strong acid. So we ignore weak acid. And we really ignore it. Some of them dissociate, but doesn't matter. So, yes. So, equilibrium concentration of acetic acid, calculate this. Oh, wait a minute. So they are asking that concentration. Okay, so goal is finding that concentration. Okay. So then we are not looking for pH. All right.
So like x times x plus 0.025 divided by 0.3.
Ice table, right?
Right.
Yeah. Let's go for ice table. Okay. Because it's not like okay. So there's no reaction, so it's not like before and after. Because there's no reaction, it's not before and after. Initially we have this, and then later, if some of that dissociate, then we're gonna have this and that, and they are looking for this guy. So let's solve for x. X times 0.025 plus x divided by this, and that's equilibrium constant. Because your reactant is acid, this is Ka, and Ka is given. So we can really solve for x. And then x is the one they are asking. So why don't you solve using our approximation? You can just assume x is small compared to that number. So my x is just 1.8 times 0.3 divided by 0.025. That's my x. Acetic ion. What next?
Can we do 31? Yeah.
31? Although I knew this one because you mentioned it, special bonus. I just want to introduce in the environment process. 31? Is
Yeah.
it 31?
Yeah.
Okay, 31. One and two. Okay, I'm going to one, two. Oh, that's three. Bottom is left of touching of weak axis with the base. The tighten because it reaches the equilibrium point. So we see the constants are equal. So base and axis have same concentration. So at equilibrium point you need 25 milliliter of weak acid to reach equilibrium point. So if you go to question 2, if you add 25 milliliter of hydroxide, or actually 5, this is, yeah. Wait. Okay, yeah. So if you use that much, that's when you have equilibrium point. Because the weak acid, when titrated with hydroxide, it turns into conjugate base, weak acid, and the make water. So if we use equal amount of volume, everything will be gone, and you're gonna have conjugate base. So the conjugate base is, you can consider as salt,